How fast will the balloon rise? A 2-gram latex balloon is filled with helium. When it is completely inflated, its shape is approximately spherical with a diameter of 24 centimeters. If the balloon is released, what is its initial upward acceleration? Density of helium is equal to 0.166 kilogram per cubic meter and density of air is 1.2 kilogram per cubic meter. Obviously, this numerical is based on um, buoyancy and flotation. Let us see when an object sinks and when an object floats and when an object has neutral buoyancy. If an object is placed in a fluid and its weight is more than the fluid it displaces, then it sinks. For example, if you take this one, the weight of this object is greater than the fluid it displaced. Therefore, it sinks. That means the density of the object is greater than the density of the fluid. Okay. Density of object is greater than density of fluid, where O is the object and F is the fluid. Remember, the weight of the object is greater than the weight of the fluid it displaced, then it sinks. Opposite is the case. Weight of the object is less than the weight of the fluid displaced, then it floats. That means the density of the object is less than density of the fluid. Suppose the density of the object is equal to density of the fluid, then it will suspend in the fluid having neutral buoyancy. Okay, so the weight of the object is equal to the weight of the fluid displaced, then that means the density of the object is equal to density of the fluid. Here you are seeing the case of solid and liquid, but it is applicable for all the fluids. That means even for the gases also. How it will be, we will see with a numerical example here. Okay. Here the mass of the balloon, latex balloon, is given to us. Mass of the balloon is 2 grams. Mass of the balloon is 2 grams. That means 2 times 10 to the power of negative 3 kilograms. Next, the gas, helium gas is pumped into the balloon. See here we are seeing the case of air. In general, the density of the air is very small. That means its density of air is 1.2 kilogram per cubic meter. That means negligible. In this case, we are pumping a gas which is lighter than the air. That means whose density is less than the density of the air. Here, we are pumping helium into the balloon. That means the helium density of the helium is much less than the density of the air. So it will float. Okay. So the principle here is the density of the object must be less than the density of the fluid. Here we are taking two gases. One is helium and another one is air. And then helium density is less than the density of the air. That is why if we pump the helium into the balloon will float. Okay. Suppose if we are holding the balloon and by any chance we lose the grip of the balloon, then the balloon flies off. This is our common experience. Okay. Here in this case, we are supposed to find out the acceleration of the balloon. Okay. So the acceleration of the balloon means the net force must be there. According to Newton's second law, sigma F is equal to ma. Am I right? So here, what is the net force? The difference in force between the buoyant force and the this one. No, weight. So Fb minus Fg is then there is a net force. Fb minus Fg is equal to ma, or A is equal to Fb minus Fg over m. Okay, here m means the total mass, obviously. Okay, what is the total mass of the balloon? That means the mass of the balloon plus mass of the helium gas. That mass of the helium gas is not given to us, but they gave the diameter of the balloon because they are saying that the balloon is spherical in shape. So when they are saying that the balloon is spherical in shape, we can easily find out the volume of the balloon. Okay, volume of the sphere we know. So volume of the sphere is equal to 4/3 pi r cube. 4/3 pi r cube. And in this r is equal to, diameter is given to us, no, 24 by 2, that is equal to 12 centimeters. That is, therefore, that is 0.12 meters. Now substituting this one, we will get V is equal to 4/3 pi 0.12 whole cube gives a value of 7.24 times 10 to the power of negative 3. 7.24 10 to the power of negative 3 cubic meters is the volume of the balloon. Okay. Now we have to find out the mass of the helium because mass of the helium is not given to us. How we find? Density is equal to mass over volume. Am I right? Here we know the volume. We can find out the mass. From this we can find out, no, m is equal to rho v. Therefore, m helium is equal to rho helium plus V, that is known to us. So 0.166 times 7.24 times 10 to the power of negative 3. That, then what is the value of this one? This gives a value of 1.2 times 10 to the power of negative 3 kilograms. Okay, so now we will add both. So total mass is equal to 2 plus mass of the balloon plus mass of the helium. M balloon plus M helium. That is equal to 2 plus 1.2 to the power of negative 3 kilograms. That is equal to 3.2 10 to the power of negative 3 kilograms. Okay, total mass is known to us now. Next, what we have to find out? FB and FG we have to find out. Now, what is FG? FG is nothing but W. Okay, so W is equal to mg. So W of we will find out this one for the balloon and also for the helium gas. So W helium is equal to, I will write W helium is equal to, that means it is the this one. First I do one thing. I find out for the air. Okay, air is equal to, that is this is nothing but FB. Okay, fluid. That is equal to rho fluid plus V fluid times gas G, acceleration due to gravity. So 1.2, this one, 1.2 times volume is equal to same volume, no? 7.24 10 to the power of negative 3 times 9.8. Okay. So what is the value of this one? This is equal to 8.5 times 10 to the power of negative 2 newtons. Okay. Now I have to find out W helium. Helium or W helium now I have to find out. So that is equal to weight, total weight. This is the total mass I already found out. Am I right? So this is equal to this into G gives the W, no? W downwards. W, it is not the helium. W I have to find out it. So W is equal to this into G gives the, yeah, total mass into G gives the W. So 3.2 into 10 to the power of negative 3 times 9.8 gives this one. So what is this value? This is equal to 3.14 into 10 to the power of negative 2 newtons. So FB minus W is equal to, subtract here 8.5, 3.14. So what is the value we are going to get? 5.36 into 10 to the power of negative 2 newtons. This we can take 5.4. So rounding, because of 3, 4, no, so I round it off. 5.4 into 10 to the power of negative 2 newtons. Now, acceleration is equal to, here I will substitute, FB minus W known to me. So 5.4 times 10 to the power of negative 2 divided by mass is equal to, here I found out 3.2 times 10 to the power of negative 3. So that gives an answer. What is the value of this one? 10 to the power of negative 3. No? So this is equal to 16.8 meters per second square. Therefore, acceleration is equal to 17 meters per second square. Okay. So here the law of buoyancy and then law of flotation, laws of flotation are applicable for not only to the liquids, it is also applicable for the gases also. But the density of the air is so small, it is very difficult to find this effect. But to demonstrate this effect, I am taking the numerical. Okay. In this case, what happens if the density of the object is less than the density of the fluid, then it floats. Okay, density of the object, the density of the object must be less than the density of the fluid. Here, that is why we are taking the helium balloon. Okay, so that the helium density is less than the density of the air, so it will float. So the data points are given to us, and then with the data points, we know. And this problem is based on three principles. One is the Archimedes principle, another is Newton's second law, and another one is law of flotation and buoyancy. Okay, these are the principles here. So law of flotation and buoyancy are here, this one. Okay, and Archimedes principle here, when the object density is greater than the fluid density, it will sink. If the object density is less than the fluid density, it will float. If the object density is equal to the fluid density, it is in neutral buoyancy and it will suspend in the fluid. Okay, that is the case. Now, according to the Archimedes principle, whenever an object is either completely or partially submerged in a fluid, then the buoyant force exerted on on the object is equal to the weight of the fluid displaced by the object. Okay, that is the principle. Based on that principle, we are trying to find out the acceleration, and then we will find out the forces, buoyant force, and then the weight. And then next, what we do is we will we will find out the net force acting on the balloon. To find out the acceleration, we have to find out the net force. Unless there is a net force, the body will not accelerate. Okay, so here the upward force, buoyant force is greater than the weight. Obviously, the balloon the balloon accelerate in the upward direction. Okay, so to find out the buoyant force and the gravity, we use the data points and then find out the net force. Once we find the net force, we divide it with the total mass of the object and then find out the acceleration. So the acceleration is this much. Okay, that's it. Hope this helps. Thank you. Bye bye.